Assalamualaikum and greeting everyone. We are from Group 4 Smart Agriculture. We'll present our project. Our supervisor is Dr. Chu Chang Chun, and the title for our project is Smart Greenhouse with PV System and Nutrient Control for Spinach. Before that, I would like to introduce our team members. So the first one is Muhammad Adam Daniel bin Abdullah as the manager, Nur Hazwani Hadira binti Shamsul as the assistant manager, Jardel Mackenzie Melvin as the chief engineer, me, Irene Iliana binti Abdurrahman as the engineer, and Amma bin Amran as the assistant engineer. A bit introduction about our project is that it was made due to the increased demand for nutrient-rich spinach due to its health benefit, including antioxidant that support heart and eye health, anti-inflammatory properties, and its sustainability for waste management. However, we can see that this day that traditional farming faces challenge like inconsistent environmental condition, seasonal limitation, pest, temperature fluctuation, and irregular rainfall. So this is one of the reason why we choose to make this project. Greenhouse farming offers a solution by providing a controlled environment to enhance growth, conserve water, reduce pesticide use, and enable year-round production. So this project aims to build a smart greenhouse system powered by solar energy to manage key parameters like temperature, humidity, pH, level, water levels, and also light exposure. So the goal for this project is to ensure optimal spinach growth, promote consistent production, and support both small scale and commercial application. There are three objectives for this project, which is the first is to develop a smart greenhouse powered supply by the solar system or PV panel. The second one is to build a smart greenhouse that have the ability to control temperature, humidity, and lighting based on sensor data. And the last one is to analyze the growth of spinach by planting using traditional method and hydroponic.
Hi, my name is Jardel Mackenzie, matrix number CE210208. So as of the problem statement in this project, I will highlight the challenges in spinach cultivation that focusing on how the uncertain global condition and the traditional farming method are impacting the production of the spinach. So as of the first point, spinach cultivation also facing the several types of challenges due to the uncertain global weather conditions. So this include the unpredictable weather patterns that may affecting the vegetable growth, and also it is significant agriculture losses, especially in spinach production. Spinach is as a very sensitive crop, requires a very specific condition for optimal growth, and it is very hard to achieve with unstable climates. So as of the second problem in this project, traditional open field spinach cultivation also facing the critical limitation such as inconsistent temperatures and unpredictable rainfall which disrupt the growth, and also exposure to pests that may lowering the qualities of spinach, and the last one, inefficient use of water and nutrients which may lead to increase the resource of waste. And additionally, the soil moisture, pH levels, and nutrients availabilities also make it more difficult in order to maintain the ideal of growth condition for the spinach. So these challenges also underline the urgent need for innovative solutions in order to improve the spinach production as well as the sustainability. So as of the tools or component that we are going to use in this project, we have ESP32, DHT11 sensor for temperatures and humidity, pH sensor, water level sensor, TDS sensor. For the body of the project, we are going to use water pipes, basin, power, we are going to use solar panel and battery, and for the software part, we are going to use Blink as of the application.
For the methodology, data from these sensors are continuously collected and processed by a microcontroller. This microcontroller evaluates the sensor readings to decide whether the plants require any action taken. The general flowchart of this PV system and nutrient control starts with utilizing the water level sensor, where it measures the water level. Then the system will measure the pH level, and if it's below the reading of 7, fertilizer will be added, following the required optimal nutrient level. Next, the temperature of the greenhouse will be measured, and if it is below 20 degrees, grow light will be activated. All the readings will be displayed on Blink for easy access for users to monitor real-time data even in remote areas. Attached beside is an example of a system Blink interface showing real-time data.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad bin Amran. My matrix number is DE220174. So I will present to you for the solution part and the conclusion part of our project. There are four solutions that we have figured out based on our problem statement. So for the first solution, we use sensor data monitoring via Blink. Uh, the TDS and pH sensor will send a real-time sensor reading to the Blink dashboard to monitor water quality and nutrient levels. For the second solution, we use remote control of grow lights and pumps, which is we add control for grow lights and water pumps in Blink. So we can adjust the light intensity or schedule based on detected issues. Other than that, we also can activate pumps remotely to maintain optimal water and nutrient level. So for the third solution, uh, we use sensor integration for monitoring plant health. The TDS sensor is to monitor water quality to ensure nutrient levels are optimal. Other than that, we also use pH sensor that will track pH level to maintain a suitable environment for plant growth. For the last solution, we use solar power system efficiency, which is the solar power setup to run sensor, pump, grow lights, and the AI system. We also use a battery for energy storage to ensure continuous operation during low sunlight periods.
Okay, this is our prototype for hydroponic. So our hydroponic will using solar panel. So the solar panel will use solar charge controller to charge the battery, and the output will use to generate our ESP and water pump and our ultraviolet lamp. So our system can monitor water present. When the blue light is on, indicates the water is present, and when the blue light is off, it indicates water is absent. On the Blink app, it will show us our pH value and our temperature value. And this is our dashboard for Blink. To activate the water pump, press the switch on the phone. The water pump will flow from the tank to the hydroponic pot and back to the tank. During night, we can on the ultraviolet lamp using the switch from the smartphone Blink, and we can on also our water pump. So this is our pH value 5 and our temperature value. So the blue light is our indicator for our water. After that, we can manual control for our water pump and our lamp. Thank you.
So for the conclusion that we can conclude of our project, there are four conclusions. That is, this project has successfully proposed a smart solar power greenhouse system designed to tackle the challenge of traditional spinach farming. The second conclusion is this approach not only enhances crop consistency and quality, but also reduce resource waste and minimize environmental impact. And the third conclusion is this project emphasizes sustainable practice, including water conservation, making it a practical model for commercial spinach farming. And the last conclusion that we can conclude based on our project is through its innovative integration of technology, the system supports agriculture sustainability and paves the way for efficient, eco-friendly farming solution. So that's all from me. Thank you.